Welcome to solverfy.
Today we're dealing with electrocyclic reactions, and we are answering problem number 7 from the Organic Chemistry book by Smith, chapter 27, section 3. So the question stem asked us to figure out the cyclic structure that would result when each of these structures, A and B, undergo a thermal electrocyclic reaction. So let's go ahead and jump right in, starting with molecule A. The question stem actually tells us that these molecules are both decatetraene molecules, which means we have 10 carbons and 4 double bonds. But I'm just going to go ahead and count our carbons because that's going to help us later on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let's go ahead and do our arrow pushing. These electrons are going to go over here, which in turn would push these electrons and so on and so forth. And these last pair of electrons would attack our carbon number 2. This tells us that our cyclic structure is going to be comprised of carbons 2 to 9, which gives us an 8-membered ring. Alright, so what I want to do is just prepare our structure and draw it in a way that we can easily see a ring. So let's move forward here, and there you go. So we're just going to draw the same thing. We know this is from carbon 2 to 9, so let's number our carbons. 6, 7, 8, 9. We have double bonds between 2 and 3, 4 and 5, 6 and 7, and 8 and 9. If we continue with our arrow pushing, we know that this is going to go over here, here, and this last set of electrons would close our ring. But before we get into that, we still have carbons number 1 and 10, right? And if we look over here, we see that carbon 1 is in trans configuration with carbon number 4. So carbon number 1 is going to go in trans. And similarly with carbon 8 and 9, we see that carbon 10 over here is in trans position with respect to carbon 7. So this carbon over here would be our carbon number 10. Alright, now the next question is, after our ring closes, what's going to happen to carbons 1 and 10? Are they going to be into the board, out of the board? We don't know yet. But luckily we have a table that's going to help us figure that out. So let me slide our page for a while and show you our table. And there's our table. Now this table shows us that what happens to carbons 1 and 10 actually depends on how many pi bonds we have in our structure. So number of pi bonds. Let's go back to our original structure and count them. We have 1 over here, 2, 3, and 4 pi bonds, which means we have an even number of pi bonds. And the question stem also tells us these structures are going to undergo a thermal electrocyclic reaction. Thermal. So that's the only part of the table we're concerned about. And since we have an even number of pi bonds, that means our methyl groups are going to go in a conrotatory motion, if you will. Now that we know that, we can come back to what we are working on over here. So conrotatory would mean that this carbon number 1, if it goes in a clockwise direction, carbon number 10 is going to do the same thing. So let's see what that's going to look like. First of all, we have to close our ring. There we go. Again, let's number our carbons. 2, 3, 4, 5, 6, 7, 8, and 9. We know that our pi bonds are now between 3 and 4, 5 and 6, 7 and 8. Now, if this carbon number 1 is going to go in a clockwise direction, that means carbon number 1 is going to go out of the page. Out of the page. Now, if carbon number 10, on the other hand, goes in a clockwise direction, that means our carbon number 10 is going to go away from the page. And that's our final structure for molecule A. And we're basically going to do the same thing with molecule B. Let's go ahead and number them first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if you notice, the only difference here really is the cis double bond here between 8 and 9. Other than that, our molecule is basically the same as molecule A, which makes it easier for us this time because we are just going to do the same process. So again, let's number our carbons. 2, 3, 4, so 3, 5, 6, 7, 8, and 9. We know that we have double bonds between 2 and 3, 4 and 5, 6 and 7, 8 and 9. And again, carbon number 1 is in trans, so carbon number 1. But this time, carbon number 10 is in cis configuration. That's carbon number 10. So after our arrow pushing, we're going to close our ring. There we go. Now, similarly, we're going to have our pi bonds between 3 and 4, 5 and 6, and 7 and 8. And let's just number them so we see which one's which. And again, since we have 4 pi bonds in our original molecule, if carbon number 1 is going to go clockwise, carbon number 10 is actually going to do the same thing. So, if carbon number 1 goes in a clockwise direction, then it's going to end up coming out of the page. But if carbon number 10 is going to go in a clockwise direction, it's also going to end up coming out of the page. So for molecule B, we actually end up with a cis octene molecule. Let me just go ahead and show you both molecules. So molecule A, we ended up with a trans octene, and molecule B, we ended up with a cis octene.